Let's review some topics for Test 2. I've listed the topics in D2L and problems that you could do from the homework. I want to point out I've noticed OpenStax. If you go directly to the OpenStax page by I usually Google OpenStax College Algebra and it'll take me straight to the OpenStax textbook. That's the problem numbering I've used. I've found that if you open it from WebAssign, they number problems throughout an entire chapter, so it's not exactly the same. So I'm referring to the OpenStax textbook that you can get directly to from the link on the syllabus or just by Googling OpenStax College Algebra. So anyway, our first topic is determine if a relation is a function. So we talked about how a relation is anytime you're assigning inputs to outputs, and we have lots of ways to do that, and one way is ordered pairs like we have here. And they don't even have to be numbers. Here we have letters in our ordered pairs. So we have A sent to B, C sent to D, A sent to C. So we know that a function has every input sent to exactly one output. So when we have numerical data, if we have an x value repeated with different y values, it's not a function. And that's the case here. We have AB and AC, so A has too many outputs. So this is not a function because A has two outputs. We also saw problems where our relations were represented as formulas. The strategy here, we're talking about, is it a function of x? If x is the input and y is the output, is it a function? We try to solve for y and see if we get more than one y value for any of the x's. So number 11 there, I just subtract 3x squared from both sides and get that y is 14 minus 3x squared. So whatever x is, I would do that computation and I would always get a single y value. So I have one output for every x, so it is a function. Number 12, however, because of the y squared, is going to wind up being not a function. If we try to solve for y, we get y squared is 6 minus 2x, and I have to take the square root of both sides, but when we do that, we have plus or minus, because if we square the negative, we get the same thing. So we're getting two y values for everything except for the one value there that would make it square root of 0. Every other number, you're going to have plus or minus different numbers, and you're going to have two outputs. So not a function, because most of your inputs have two outputs. And then we can do the vertical line test if we have a graph. This one here is going to pass it. I've made several different vertical lines. Every vertical line that I do is going to hit this graph exactly once. So for every x value there representing the vertical line, I'm getting only one y value. So that one passes the vertical line test. No vertical line hits more than once. So it is a function when it passes the vertical line test. Every x has one y. Here's one that's going to fail the vertical line test. If a single vertical line, any vertical line, hits more than once, then you have an x value with more than one y value and it's not a function. So this one, lots of vertical lines are going to hit more than once. Infinitely many vertical lines there are going to hit twice. So this one definitely fails the vertical line test and is not a function. Okay, next up we had evaluating functions. So if we have a function that we can write in function notation, f of x in this case is negative 5x squared plus 2x minus 1 is the one I picked. We can evaluate it at numbers as well as small algebraic expressions. We can plug in other functions, other variables. This one asks us to do f of negative 3, f of 2, f of negative a, and f of a plus h. It also asks you to do negative f of a, which would be to multiply the function by negative 1, but that's not really evaluating a function. I wanted to focus on evaluating functions. So if I want to do f of negative 3, I just take x out and plug in negative 3. So we'd have negative 5 times negative 3 squared plus 2 times negative 3 minus 1. So we take out every x and plug in our input of negative 3. If you evaluate that, you get negative 5 times 9 minus 6 minus 1, which will work out to be negative 52. And then f of 2, similar. I take the x's out, plug in 2. I get negative 5 times 2 squared plus 2 times 2 minus 1. And that one I worked out and got negative 17. And then the other two on this problem, we're going to get solutions that involve a and a plus h or a and h on the second problem there. F of negative a, again, I can plug anything into a function. I take x out and I plug in the input. So for f of negative a, I would take x out and put negative a in. And there we can cancel some negative signs here or do some things with the negatives. We have negative 5 times negative a squared is going to be a squared. Squaring it's going to cancel the negative sign, so we could just write negative 5a squared. And then 2 times negative a would be minus 2a and then minus 1. F of a plus h, no, it doesn't really matter to us right now, but f of a plus h is a quantity that's very important in calculus later on, is one reason why I think they're going ahead and putting it in here. But we need to practice in college algebra being able to plug other things into functions. We can do f of a plus h. So again, we take x out, and this time we put in a plus h. So we have negative 5 times a plus h squared plus 2 times a plus h minus 1. And that's f of a plus h. We can expand it if we want here. We can multiply stuff out. A plus h squared is a plus h times a plus h. You have to FOIL that out. You'll get a squared and an h squared, but in the middle you get 2ah when you do the inner and the outer terms. So we have negative 5 times a squared plus 2ah plus h squared. And then plus 2 times the quantity a plus h we can distribute and get plus 2a plus 2h minus 1. And then we could go ahead and multiply through by the negative 5 and get a final expression. There's no like terms or anything. We have an a squared and an a and an h squared and an h and one that has a and h in it. So we could multiply everything out, but there's no like terms to really simplify or anything. Then we talked about finding the domain of a function from a formula, and the domain are all of the possible inputs. If it's called x, then all the possible x values that I could plug in and get a real number. Okay? And with our basic operations that we're using to build our functions right now, we can't divide by 0 and we can't take square roots of negative numbers and get real numbers back. So I picked one here that has a square root. F of x is the square root of 4 minus 3x. So if we want to get real numbers, we have to have 0 or positive values under the square root. We can't have negatives, so we need the 4 minus 3x here to be greater than or equal to 0, and we can solve that inequality and we'll have our domain. So I subtracted 4 and got negative 3x is greater than or equal to negative 4. Divide by negative 3, which is going to flip the inequality sign around because I'm dividing by a negative, and I get x is less than or equal to positive 4/3. So that's my domain. Any x less than or equal to 4/3 would give me a real number back. As an interval, that's negative infinity up to 4/3. And we always put parentheses on infinity because there's no endpoint there. And then the 4/3 is included in the domain, so I put a bracket. Okay? If I plug in 4/3, I'm going to get f of 0 is 0, square root of 0, which is a real number.